Hi, in this video I'll be telling you all about my physics extended essay experiment in which I found the focal length of 4 lenses, and in the second part I use those 4 lenses to make a invisibility cloak. In this first video I'll be showing you how I did this experiment, and then I might make a second video showing exactly how I set up this Rochester cloak and how it works, which I thought might be interesting. For my experiment, I was doing some research online and watching some YouTube videos about it, and most of them weren't very attainable for me as a high school student because they use a lot of specific apparatus and materials which I don't have access to, especially during quarantine, because I did this last year. So I thought I would make my own video to make a more accessible version of this experiment. So I'll start off, of course, how I got my materials and how I set everything up. So the only thing I had to purchase for this experiment was the lenses for it. And these are the ones that I bought. I've got 2 of these and 2 of this one. I bought these as 113 millimeters and 80 millimeters, but from the experiment I learned that these are not the exact measurements, which is another reason why this experiment might be helpful for most people. So I bought these from Alibaba, which is a website where you can directly buy something from the manufacturer. I'll put the link of where I got them in the description because they were really cheap compared to Amazon and those kind of websites. The formula I will be using to find the focal length is 1/u plus 1/v equals 1/f, where u represents the distance from an object to the lens, v represents the distance from the lens to the clear projected image, and f represents the focal length. By finding u and v first, we will be able to use them to find the focal length. I made this diagram to roughly show you how the experiment will look like. Alright, so to set up this experiment, you first need to make a stand for the lens. You can purchase official lens holders, but I decided to make my own. What you need is a poster board or cardboard. For my extended essay, I use poster board, but I will show you how to make this with cardboard. The stand I'm making is 7 centimeters by 5 centimeters. The first step you need to take is cut out 2 rectangles from the cardboard. This can be done using a precision knife or regular scissors. Once you have those 2 rectangles cut out, you need to stick them together. You can do this using regular or super glue or tape. In this example, I'm using tape, but I recommend using super glue. Next, take a precision knife or scissors and make a 3 to 4 centimeter cut in the middle of the rectangle. Make sure it is deep and thick enough for the lens to fit to use during the experiment. I recommend also going through the bottom rectangle so that the lens can properly stand up. The last step to the setup is to get a desk lamp. The one I'm using is movable, which makes it easier to use during the experiment. Next, find an image on a paper. I found a picture of a zebra and printed it out since it had a clear design and sharp lines, which will make it easier to determine whether the image is clear during the experiment. This is really important. All you have to do is stick the paper on the lamp in front of the light, like this. Finally, lay out a ruler or tape measure on a flat surface and make sure it starts at the light source. The last material you need is a piece of paper or a white surface. Once you have all your materials, you can start the experiment. Start off by deciding which distances you want to try for your lens. If you know what the intended focal length your lens has, I recommend using 3 different distances less than twice the focal length, 1 that is twice the focal length, and 3 distances that are more than twice the focal length. Once you have decided the distances, place the lens in its holder at this distance from the lamp, and use the white surface to determine where the image is most clear. The distance the white surface is from your lens should be written down at this point. If you are using 1 measuring tape for the entire experiment, all you have to do is subtract the distance from the white surface is at from the lens distance from the light. Repeat this process for all distances of the lens. Now that you have u and v, it is time to plug them into the formula. I've plugged in all the numbers that I know, and I ended up with a focal length of 5.71 centimeters. With an intended focal length of 8 centimeters, this is very different. This next table is the data that I got during my extended essay experiments, which shows how important it is to have at least 7 trials and taking the average of them all. According to this data, the focal length is 7.2 centimeters, which is a lot more accurate and closer to the intended focal length. Thank you for watching this video. If it was helpful, give it a like so I know that I should make more videos like it.